Hello, welcome to Astronautics for Exploits. This is Dr. Ayanshola Ogundele. Water, an indispensable and major driver of space exploration. The focus points are as follows: water in space and water as key driver of space exploration. In a vast expanse of deep space, water, one of the most valuable resources for sustaining astronauts on long space missions, is indispensable and the key driver of space exploration. In space, water is necessary for drinking, breathing, and producing rocket fuel, for operating moon or Mars space-based systems, or for operating spacecraft. At International Space Station, about 80% of the water being used by astronauts is recycled from sweat, urine, and exhaled breath. Various recycling methods have been developed to purify and recycle water in the space station so as to make it safe for drinking. The Environmental Control and Life Support System, through advanced water recycling technologies, is used on board the ISS to recycle water from different ISS water resources. Various space exploration missions have been channeled towards exploring the solar system and search for habitable planets that might contain water and alien life. As humans plan to explore this space further and engage in long-term space exploration missions, the knowledge gained from recycling at International Space Station and water-finding missions will be useful. Water in space. Water, an essential resource for life and for astronauts in space, is one of the key factors in space exploration. Presently, search is ongoing for planets and moons that harbor substantial water. Evidence of stable liquid water elsewhere could indicate an environment beyond Earth that could sustain the formation of extraterrestrial life. Water can be used as fuel and necessary for astronaut survival needs in space. The picture here illustrates an artist's impression of water plumes escaping from Saturn's moon Enceladus. Water as key driver of space exploration. And as key driver, we have the following: water recycling, evidence of life, fuel, life support, renewable resources, biosignature, and resource extraction. In space, drinking water is very essential for human survival. As a result, several space agencies are researching and investing on how astronauts will have available water in space, and up to 80% of the water on the International Space Station is recycled. The water astronauts living and working in space are drinking is recycled from their colleagues' sweat and exhaled breath, collected as condensation on the space station's walls. The picture here illustrates Moon's Clavins crater, depicting water trapped in the lunar soil. European Space Agency and partner universities have been working to develop a self-sustained ecosystem in a box that astronauts could take with them on a spacecraft to explore the solar system endlessly. Recycling waste such as urine and sweat, the system uses a chain of filters, bacteria in bioreactors, and chemical reactions to produce clean water and food. The goal is to become completely self-sufficient so that astronauts could travel through deep space forever, producing the three basic elements of life: water, oxygen, and food. NASA's LRO found evidence of water around the moon's southern pole, as illustrated in this picture. Collection of water from urine and other sources is vital to maintaining sustainable water sources aboard the International Space Station. Urine recycling plays a significant role in the water collection on the ISS. The spacecraft systems are designed to collect, filter, and purify urine to extract water for consumption. Condensation collection is another method used to gather water. Moisture in the air is captured, condensed, and then processed through a filtration system so as to ensure its purity and to produce potable water. The picture here illustrates Jupiter's moon Europa, which is a water world with a deep global ocean beneath its outer ice crust. Evidence of life is one of the key reasons why water is being mined and also being investigated. Water is essential for life. The primary evidence for potential life on other planets is the presence of liquid water, as it is considered a crucial ingredient for life. Presently, scientists are actively searching for planets within the habitable zone where liquid water could exist on the surface. Examples include the subsurface oceans on Jupiter's moon Europa and Saturn's moon Enceladus, where geysers spewing water vapor have been detected, indicating the possibility of a liquid water environment beneath the icy crust. The picture here illustrates artist's depiction of a Isian planet, a large ocean world with a hydrogen atmosphere. Examples of evidence for water on other celestial bodies are as follows. Evidence from probes suggests a vast subsurface ocean with potential hydrothermal activity, a key factor in the possibility of life. Geysers erupting from the surface eject water vapor and other chemicals, indicating a subsurface ocean. And also, evidence of past lakes and dried-up riverbeds suggests Mars may have once had liquid water on its surface. The picture here illustrates artists' cutaway representation of the internal structure of Ganymede with a liquid water ocean sandwiched between the two ice layers. Fuel. Water can serve as a source of hydrogen and oxygen, which can be separated through electrolysis and used as rocket fuel, making it a potential fuel source for space exploration, particularly when accessing water ice found on celestial bodies like the Moon or Mars. Essentially, one can split the water molecule to create usable fuel. Water is being used as fuel. In order to utilize water as fuel, an electric current is passed through it, separating the hydrogen and oxygen atoms, allowing them to be used as propellant when recombined. The picture here illustrates K2-18b, which has been shown to have water and may have temperate conditions that could support life. Benefits of using water as fuel are as follows. Water ice is believed to exist on various celestial bodies, providing a potential refueling source for spacecraft. Compared to traditional rocket fuels, water is relatively lightweight, making it more efficient to transport in space. The combustion products of hydrogen and oxygen are primarily water vapor, considered less harmful to the environment. Two possible versions of LHS 1140b, with and without an ocean, is illustrated in this picture. Life support system. The environmental control and life support system includes a water recovery system that collects wastewater and sends it to the water processor assembly in order to produce drinkable water. The EPA also recovers water from urine using vacuum distillation. The European Space Agency is developing closed-loop life support system in order to support a number of rats indefinitely in a comfortable habitat. A complete ecosystem, such as from our environment, created with one purpose, to keep the rats healthy and happy. The picture here illustrates an artistic impression of the Kepler-138 planetary system. Renewable resources. Water can be considered as a renewable energy source because it can be split into hydrogen and oxygen through electrolysis, providing a fuel source for spacecraft propulsion, particularly for small satellites or maneuvers where the hydrogen and oxygen can be recombined to create thrust. Water as a portable fuel can be potentially harvested from icy moons or asteroids in space, making it a valuable resource for deep space missions. Enceladus, one of Saturn's many icy moons, now known to possess underground reservoirs of liquid water. Advantages of using water as fuel are Water is a relatively safe and stable substance to store on board a spacecraft compared to other fuels. When split into hydrogen and oxygen, water provides a good amount of energy per unit mass. The picture here illustrates Hubble that finds first evidence of water vapor at Jupiter's moon Ganymede. Biosignature. Because water is considered a key ingredient for life, finding liquid water on other planets is a strong indicator of the potential for extraterrestrial life. A planet with less carbon dioxide in its atmosphere than other planets in the same system could have liquid water on its surface. The presence of certain compounds like dictopyrazines and dihydropyrazines can indicate the presence of recent life and hydrothermal processing. Model of Callisto's internal structure showing a surface ice layer is shown in this picture. Resource extraction. On planets like Mars or moons like Europa, where water ice exists, it could be extracted and processed in order to provide drinking water, oxygen for breathing, and hydrogen for rocket fuel. NASA is developing technologies to extract water from the moon, Mars, and asteroids. This water could be used for drinking, growing crops, and producing rocket fuel. Researchers are exploring methods like drilling and solar-powered furnaces to extract water from ice. NASA's Viper mission will search for water ice at the lunar South Pole in order to help inform future extraction techniques. An illustration showing the Europa Clipper as it flies past the Jovian moon Europa is shown in this picture. For more information, contact Astronautics for Experts. You've been watching and listening to the presentation on water, an indispensable and major driver of space exploration, presented by Dr. Ayonshola Ogundele, with the focus points water in space and water as key driver of space exploration. Thank you.